Everyone, and welcome to the first Queen's Data Analytics Data Science lesson. I'm happy to have you all here. I'm sorry if you weren't able to make it out last night, but hopefully we can find something that works for everyone in the future. Without further ado, let's get started. So one of the things that I want to do with these sessions is I don't want to just give you some code and have you not understand what you're doing and why. And I also don't want to just give you a theoretical math lesson, right? Because both of those aren't very useful and they're not very interesting. So I want to kind of combine it. So what I'm going to start these sessions off with is a bit of a problem statement. So something that's an issue that data scientists or computer scientists have had to actually solve, right? So that way, when you come across that issue, which you will, you can think, oh, what are the tools that, people use? Like, I know how to identify when to use the hammer. I don't just know how to use the hammer, right? So you can pick different tools for different problems, if that makes sense. So the problem we're going to be addressing today is how do you represent and conceptualize a data set? And the answer is what we're going to be getting into. So the first tutorial is going to cover data frames. So data sets and data frames, traditionally, if you've ever used something like Excel or Google Sheets, you're going to have seen them like this, right? So this is what a typical data set looks like. You have different columns that represent different variables, and then each row represents a different entry, right? So the first guy, the student number ends in 149, he's 22, he's in English, his name's Josh, and he stands at 164. So that's how you read a typical data set. And there's a lot you can pick up from this. So for instance, the student number and age, those are both numbers, right? But you wouldn't treat them numerically the same way. For instance, you might get the average age or the standard deviation of the age to see how your age is distributed amongst the members of your data set. But you wouldn't do that with your student number, even though they're both numbers, they're both integers, like they're identical, right? But the context and what they represent is a little bit different. Similarly, or dissimilarly rather, your program is not a number at all. It's what we call categorical variables. So you have a set of programs that you can belong to, and each one is completely independent. They're not continuous. It's an unordered set, right? It doesn't matter if you represent the programs as English, engineering, then commerce, or commerce, English, and engineering, depending on what you mean, right? You can't go halfway between English and commerce. That doesn't make sense. You can't do English 0.5, right? So that you'd treat differently. Names you'd also treat very differently. They're strings, that's just raw text. That's a whole field in and of itself. NLP is huge. We're not going to get into all that. And if you've ever taken linear algebra, when you set numbers up in a certain way, if you just have a bunch of columns of numbers, you might recognize that as a matrix. Now, if you haven't taken linear algebra, or you're like me and you're taking it in first year, or when I did take it in first year, and you're like, I don't understand this, I don't like this, don't worry, you don't need to think about the numbers this way. I'm just going to point this out for people who are taking linear algebra or have taken it and might want to connect this representation back to the math that you're learning in class, because it can make your time analyzing data easier when you understand these tools, because linear algebra opens up a lot that we can do in terms of numerical operations. There's a lot we can do when we conceptualize columns as vectors and data sets as matrices. And if you're in linear algebra and you're like, why the hell am I learning what a matrix is? What is a vector? Like, I know I didn't care. And then I realized that's kind of the backbone of data analytics and machine learning. And I was like, oh, that's why. So I kind of just want to point this out. So for people who are taking it, they kind of get that insight. So you can represent your columns as vectors, right? So each vector or each column in the table, right? That's just a row of real numbers, right? So your income is 140, 130, 240, and you can conceptualize that as a high dimensional point, which might sound a bit counterintuitive or difficult to wrap your head around, but it's not about the visual, it's just about the algebraic properties that we can derive from that. And this might seem very abstract and very weird, but if you've ever made a grade calculator before, one of the things you might have noticed is that, or one of the things you would have done is taking the dot product, right, of your grade, your score in a class, and the weight. So the way you calculate your grade in a class is you dot product your score and your weight factor, and then you divide that by 100, and that gives you your grade in a class. And that's what Solus does. That's what OnQ would do. If you've ever made a grade calculator, that's probably what you did. You might not have conceptualized it as a dot product, but that's what it is. And for those of you who don't know what a dot product is, it's basically you multiply each element, corresponding element, and then sum them. So you do 68 times 5 plus 62 times 5 plus 72 times 10, and so on. You take that final number and then divide that by 100. That would give you your grade in the class. So there are different tools and different ways we can represent data sets. So as I've already mentioned, you might represent them in Excel or Google Sheets using that traditional data set notation. If you wanted to think about them as more of a matrix in a very linear algebra, math-heavy way, you might use MATLAB. For my homies in engineering, you might use MATLAB a lot. CS, you might, depending on the courses you take. You can also represent data using SQL and then R or Python. We're going to be looking mostly at Python just because it's very, very versatile, and most of you should have experience with Python. If you don't, that's okay. This is going to assume a little bit of programming knowledge. Most of the Python won't be too difficult to pick up, and if you ever have any difficulties or questions, feel free to ping me or any other members of the data analytics team. I'm always happy to hop on a Discord call. I'm always happy to help you guys figure that stuff out. So what we're going to use is a tool called Pandas, and that lets us represent a data frame in Python very similarly to how you might represent it in Excel. So you're not going to be visually seeing the data set very often. You can print it out, and when you do, it'll look something like this. So you have your columns and your rows, but this lets us combine the simplicity of conceptualizing a data set like an Excel spreadsheet with the power of Python lists, because we can take all that data, convert it to raw Python types, and then do all our crazy for loops, custom functions, etc. in a Python environment. And if you have a background in programming or you're a computer science student, that's very, very useful because you're probably very comfortable with these programming languages and that logical way of thinking. So to be able to manipulate a data set in that way with the freedom of Python is a very, very powerful tool that you should use to the fullest extent possible. So now let's get on to the coding. So I just have to drink my coffee before it gets cold. So if you go into the Discord and the announcements, okay, yes, right. I just got pinged while I was recording this. You'll see a few links here. So we're gonna open them up. So this is our data set. This is what we're going to be looking at today is Montreal Airbnb listings. So if you look at this is in Google Sheets. This is kind of the traditional way of conceptualizing a data set. You'll notice that, okay, we have IDs, that they're numerical, but I don't think we would really treat them as numerical. We'd treat them more as strings, or I guess identities, right? They're unique identifiers. We have the name, we have the host ID. Here we have an empty column, which is interesting. Latitude, longitude, price. So we see all these different things, and it's always great to open up your data set in an application like Sheets or Excel just to visually play around, kind of get an idea of what's going on. This is from Airbnb. So Airbnb posts a lot of data. If you ever want to do a project, I would highly recommend using Airbnb datasets. They post very well maintained, very clean data sets. They're very easy to use. Yeah, I really would recommend using Airbnb for data science projects, which you should be doing. Full disclaimer, I support code stealing and I support project plagiarism to an extent. If it's me, steal it. So this code, what you should be doing is we're going to write some code today. You're going to take that code, you're going to modify it, maybe look at a different data set, you're going to play around, and then you're going to put that on your GitHub as your project. So that way when you're applying to internships or whatever, you say, oh yeah, this is the code I did, because you wrote it. You're going to write it. I'm going to teach you how to do it, but I'm telling you, take it, steal it, copy it, change it a little bit, and post it on your GitHub as your own, and that way you can have code that you wrote and you understand that, looks at a real data set. And that'll give you an edge when you're applying to internships, and it just shows you have some experience in the field. So that's the first link. The second link that we have is a Google Colab link. So we'll open that up. Okay, so this is kind of like the answer key. This is the tutorial code. So this is kind of in depth. So if watching a video isn't really your speed, you can go through, read it here. All the information will be here. But we'll be coding it ourselves, just to make it more fun, more interesting. So I'm gonna move that over here. And then our last data set that our last Google Colab, this is the starter code. Oh, nope, of course not. It opens over here, yada, yada, yada. Okay, so, so this is our starter code. So what you're gonna do is you're gonna go File, yeah, I think you're gonna make a copy. And then you have your own copy that you can edit, and you can save. You can put on your GitHub. It's your code. So the reason I'm giving you starter code is some of this stuff is kind of verbose, and I just want to give you some starter code to work with. But I want you to write most of it yourself and just kind of copy. You can go through the tutorial and just click play if you want. But if you're kind of really new to this, you really want that in-depth understanding of what's going on, I recommend following along and coding. So the reason we're using these Google Colab things is they let us run code in the browser, right? So I can say x equals 5, y equals 3, print x plus y, and this should give us 8. It'll take a little bit, but you can run Python. What these allow us to do, see, we got 8. These allow us to run Python in the browser. And this is really great. It's really important because we don't have to worry about the discrepancies on different machines. So some of you might be using Mac, some of you might be using Windows machines, you might be using a really old Mac, you might be using Linux. I don't want to troubleshoot that. I don't want to have to deal with that. If you follow these links, it will work, provided you're using a browser that is half decent. So that's why we're using these Google Colabs. You can share them. You can put them directly on your GitHub. If you just go File, save a copy in GitHub, you can post these directly to your GitHub. You have to sync up your Google account and your GitHub. That's a thing, but not that hard, and it's great for throwing projects up there, which I would highly recommend. You want to keep those little green dots popping. So anyways, without further ado, let's kind of get into this. So the first thing we're going to do is import pandas as PD. So this is the library. This is the tool that we're going to be using to use these data sets. So I'll just go through the code. So importing it is bringing it in. As PD is we're saying, okay, so grab this library and change the variable name from pandas to PD. So that way we don't have to say about pandas every time we want to call a pandas function. Import pandas as PD, that's kind of the standard. So if you follow any tutorials online or copy any code from Stack Overflow or use ChatGPT, that's what they'll use. This URL is going to act as the file path. So if we were running this code locally on our machine in VS Code, we might think of having a CSV in one file and our code in another and saying, okay, go grab the CSV of this file and bring that in. What we're doing here is we're just giving it a URL. So we're saying the path is on raw GitHub user content. So what this is this is on the QDAA tutorials GitHub, which I will link somewhere, probably down below in the description. And if you go there, this is just the raw data. So it's the exact same thing we saw in that spreadsheet, just raw, and we can import it directly. You can import from Google Sheets. It's just a bit more verbose, and you have to sync your Google account, and some of you might not have Google accounts, so I don't want to have to deal with all that. So I'm just going to use this for this tutorial. You can also upload your files and use them that way, but then you have to download it. The reason I'm doing this is just because it's one line. It's a lot easier. You copy this, and then you can get started. So you're going to run this, you click run, and you see that check mark means it ran with no errors. You have to run this. You have to run each cell in order. So it's not like a big Python file where you have all your code and you click run and it goes boom, 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 boom through everything. Each of these cells are their own chunk of code. So if you have two cells, right, and I say, x equals, actually, I already used x. Let's go with z equals 10, and then x equals z plus 5, you know, from reading it, we'd say, okay, well, z is defined here, and now we're calling it here, and if I run this, it should work, but z is not defined. So we have to run that cell, and then this cell, and then it'll work. We don't need these, so we can get rid of that, but that's just an aside. I know some people had some issues with that during the in-person tutorial, so I just figured I would mention that here now. So let's actually bring in the data. So we're going to have our data frame, and we're going to call that df. So df stands for data frame. That's going to represent that big object. So we do read CSV. So this is saying use pandas and read a CSV file. So it takes in an argument, which is the file. So we're going to pass in the location of that file. It's going to go there, grab that, turn it into a pandas data frame. So that's going to be something like this. And then, what the hell? Okay, sorry. And then we're going to have that as a data frame object. So we have our URL. That's just this string. So we pass that in, and that should give us the data frame. And so if we run that and we don't get any errors, now what we can do is we can print out some of the values. So if we do df.head, now that we have our data frame object, there are a lot of different methods and properties, right? So if you think of an object having different attributes, different methods you can call on it, one of them is the head. There's a lot of different tools that these data frames come with. Head is a very common one. It's used in multiple different languages. It's used in MATLAB and R, I believe. And basically what head says is just give me the head of that data frame. Print out the first few rows. So we df.head, and we see, okay, yeah, we got the ID, name, host, blah, 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 all this, which looks very similar to this. It's all these same columns. Another thing to mention is that in a Jupyter notebook or a lot of Python environments, you don't actually have to specifically wrap everything in a print statement. If you just say df.head, it goes straight to the standard output. So that can save you some time, less typing. Okay, so now the way that we index these data frames is in Google Sheets or Excel, you might go click on the column you want, or you'd say, oh yeah, grab column A, grab column B. Pandas works a little bit differently. It uses sort of it follows the Python convention of like this dictionary style indexing. So you pass in the column name as a string, and that's the column you end up getting. So what we're going to do is we're going to print out all the column names. That way we can just see them and copy and paste them. So for var, it's just going to be short for variable in df. So this is our data frame object dot columns. So this columns is a property of the data frame object, and that'll just return all the columns as sort of an iterable, kind of like a list. And then we can, I think if we just do var, it should just print out. Nope, okay, not in a for loop. I was wrong about that. A little bit of live learning for you guys. So if we print them all out, we get all the column names. And this way, if we want to grab a long one like calculated host listing count, we don't have to type that whole thing out. We can just copy and paste it. Because the way that you actually grab code is by indexing it like so. So we do df at prices. So this will return the column for just the prices. So it'll return this as a pandas column. Now I don't want to work with this data type as a pandas column. I want to bring it back to a Python list. So what I can do is I can So I have my prices. I can say prices equals prices dot to list. So this is a little bit dangerous, but what we're doing is we're saying prices equals the data frame at that column. So we're grabbing that column from the data frame and we're storing that in a variable called prices. Now we're assigning, what we're doing now is that's our first line. We assigned it to that. And then our second line, we're saying prices dot to list. So take that and don't have it as a pandas data frame column, just have it as a Python list. So that's with this to list method. And then store that in prices. So it's kind of destructive because what we're doing is we're storing a variable called prices, then we're overwriting it. But as long as you're conscious of that and you only do that with a variable you don't want to reuse, I know, because for the sake of this tutorial, we're not going to be reusing prices, that's okay. Then you should be fine. And then we can, we can print prices. Oh, it's price, my bad. So yeah, we can see that it's indexed with a string. We assign that to a column. We convert that column to a list. Actually, I'll just comment these out. So grab column, convert to list, print list. And then here we can see 190, 349, 160. And if we go back here, 190, 349, 160. So that's this list. And my Chrome is being a bit funky. All right, so that's all fine and dandy. So now what we're going to do is we're going to plot some stuff. So I'm going to import another library to help us display some stuff. So import matplotlib. .pyplot is plot. So this is another one of those common conventions where whenever you import matplotlib and pyplot, you always call it plt just as a short form. I know it might look weird to not have all the import statements at the top, the way you might do in a script or a software development set, but in data science and Jupyter Notebooks specifically, it's common to just kind of import as you go. So if that notation is a bit confusing, that's why. So if we do, actually I'll just leave this as that, make another cell, plot.hist. So a histogram is what we're going to be using to plot. Histograms, they're used to show the distribution of data. So if you think of what a bell curve is, that shows you how your data is distributed over a variable. And so what histograms do is they allow us to kind of grab these buckets and say, okay, so how many, let's say, your age can range between 0 and 100, and we have a bunch of people. How many people are between 0 and 10? So how many kids do we have? So if you have 10 kids, we'd store that at let's say that's 10. And then 10 to 20 is, let's say there's 30, so it'd be up here, right? So it's how many people fall into that range. And that range is called a bin. So if we plot the prices, so our first argument is the X value or the prices. Then we can specify the number of bins that we would like. So this is what's called an optional argument. So I'm going to do bins equals 20. You don't have to throw that in there. It's just an optional parameter. So they'll figure it out by default. They'll do something. But this lets you specify it if you really know what you want to do, or you know what you're talking about. So I'm just going to say 20 here for the sake of simplicity. And for color, I'm feeling quite particular today. I'm going to go with a good old CCD 177, and edge color equals black. So anything with an equal sign, you don't have to include. The code will run without it. They're just optional arguments that if you really want to fine tune what you're getting. So when we plot this, always gotta include your plot.show, or you get all this other nonsense out at the end. So that's strange. Let's look at this. We're only getting one bump. Why is that? So if we read the values here, we say that, okay, between 0 and like 7,000-ish, there's about 8,000 hotels, and at all the other prices, there's 0. So what's going on here? Well, if we do some exploratory data analytics and we kind of examine this, if let's get the max of our prices list, we can see that there is the maximum value of $129,000 per night. So there's one really expensive Airbnb in Montreal, which is a bit bizarre, and it's kind of fucking up our data set. We don't like that. So we can do another optional argument. So I'll just say over here, range equals 0 to 1,000. So this means only look at the hotels that are between, Airbnbs that are between 0 and 1,000. So this is another optional argument. See, the code ran without it, but now we're just going to say whatever range you're coming up with normally, that's wrong. We'll use this one. And when we do that, we get a lot nicer of a curve. So the thing to keep in mind with these optional arguments is they might seem a bit overwhelming, but you really don't need to kind of have them all memorized. You don't need to worry about them. When I was writing the code for this and doing that, like planning this tutorial, I got that first plot and I was like, oh shit, that this data is screwed up. What do I do? So then I Googled, how do I deal with this max thing? And then I found, I think on ChatGPT, they were like, oh yeah, you can use this ranged argument. I'm like, okay. And that's how I learned it. So I didn't memorize that. I didn't just, walk around every day knowing that. I ran into the problem there, and then I used other tools to solve it. So I just want to highlight that as an example of you don't need to memorize syntax. That's not very useful. Just knowing, okay, what is the problem? How do I find, like what might be causing that problem, and going to find the solution? That's the important part. Memorizing code, well, you might have to do that on your ridiculous handwritten paper tests for all those you poor bastards in CS. In the real world, when you're actually trying to solve actual problems, it's not very important. Memorizing syntax is not important. Knowing how to find the answer is. One of the most powerful statements you can say in tech is, I don't know, but I know how to find out. So always remember that mantra, and yeah, always look for ways to solve your problems. So now that we have our histogram, let's move on to the next thing. So this is kind of the plotting section. We'll do a bit more plotting later, but now we're looking at all these Airbnbs, and we can see from this plot that it's sort of normally distributed. And so, most of them are between 0 and 200, and then after 200, they kind of start to taper off a bit. There's not really that many after 600. But let's say, you're writing an article, and you want to find the best Airbnbs that are less than $150, right? So you only want to look at those ones. You don't want to look at all the other Airbnbs. We can use what's called a logical array, and I just realized I gotta open this for y'all. So logical arrays, forgive my god-awful drawing, but this is what the live lecture got, so I just figured I'd keep it authentic and keep it here. They're arrays that represent whether or not a particular index is true. So so if you have an array of data or a list of data, let's say numbers or something, and you want to find out which of those satisfy a certain condition and which of those don't, you can use what's called a logical array. And this logical array will be used to throw back into the data frame and say, okay, get me all of these ones and don't get me these. So it's used for subsetting and only getting a certain portion of the data. And why might we want to do this? Well, let's say we want to analyze hotels that are less than $150. So to just give you a quick example of what logical arrays might look like, let's say my data is I have a dog, cat, Santa, Sean, who goes to Western. He's in Western Eng. Fuck you, Sean. And a snake. We have all of these, and we want to say which ones are pets, right? So we can use a logical array to represent this. And so the ones that are pets, well, dog is a pet, so we'd say true. Cat is a pet, it's a true. Santa Claus, not really a pet. Sean, he wouldn't make a good pet. And a snake, I like snakes, so I'd say they're a pet. So you see, if we wanted to say, okay, pandas, go get me all of the entries in this data frame, and you could conceptualize this as just being one column in a larger set. So maybe you have this is the pet type, but then you also have how much fur it has, how much weight it has, how much it poops on a day on average. You want to say, okay, I'll go to this data frame, get me all the pets. So it would just go and get you, you'd pass this in, and it would say, okay, I'll get you all the ones that have a true, and I won't get you the ones that say a false. Likewise, for a numerical example, because that's probably what you'll be using more, we could say when x is greater than or equal to 10. I realize I fucked up my signs here. I was kind of embarrassed, and I showed this in a live lecture, so I'm going to show it here. Keep that authenticity. I was too lazy to change it afterwards. So if x is greater than 10, for 12, that would be true. For 8, that's false. For 9, that's false. For 1/3, that's false. But for 11, that's true. So if we said, okay, go get me all of the ones that are greater than or equal to 10, we pass in this logical array here, we would get 12 and 11, and the indices corresponding to that. So if we go back over here and let's put this into practice. So we want to get some cheap Airbnbs. So we'll indices of cheap Airbnbs. The way we do this, it's a bit bizarre, but we just say data frame at price less than or equal to 150. And I'll do this. We'll print out the first 5, actually I'll do 10. So we get into the prices category. All the ones that are less than or equal to 150, we have those as true, and all the ones that are more expensive we have as false. So we can see that the first 4 should be more than 150, and then the next 3 are. And if we go back to our Google Sheet, we can see, oh yeah, we have these 4 here are more than 150, then these next 3 are less than 150. It's weird. Yeah, and that corresponds with what we have here. So now if we want to have a data frame that is only these cheaper prices, we can say cheap data frame equals our data frame at indices of cheap Airbnb. So we pass in this logical array, and what pandas does is it gets this array that's false, true, true, and keep in mind it's way longer than this. It's like 8,000 elements or whatever. I just printed out the first 10 to compare. So it's going to go through all of them and say, okay, the first row, don't grab that. Second row, don't grab that. Third, fourth, But then number 5, 6, and 7, it will grab those. So we'll do that, and that'll assign that to a new data frame called cheap data frame. And if we do cheap data frame dot head, we can see it prints out a new data frame, and we can see, okay, all these prices are less than 150, and it preserves its order. So if we go back over here, we can see 50, 76, 121. These three. My computer's acting up. Sorry about that. It kind of preserves that order. So we have 50, 76, 121, just like we saw in our original data set. Okay, so now if we want to mess around with the latitude and longitude, we can do some cool stuff. So we can grab the latitude like this. Actually, this would be a good time to pause and see if you can look back at the previous code that we've written and see how would we grab the latitude as a list? So what you might want to do is you would, where do we do it with prices? We do that, see, we do that with prices here, and we have all of our columns here. So if right now, pause it and see if you can do that on your own. Okay, so now that I've given you a second to pause that, I'll show you how I do it. And so I would do cheap data frame at, we're doing latitude first? Yeah. And I'm just going to convert that to a list in one line. We could do the whole double reassigning thing, but that's too much. That's more code. And the same thing with longitude. So we have that now. And we can do a scatter plot. So what a scatter plot is that's like sort of an X and Y sort of pair. So you can plot different points on it. So if I do plot.scatter 5 and 3, and these typically take arrays as arguments, we can just do this. And we can see it points x of 5, y of 3, right? So what we're going to do now is we're just going to throw in a longer list with all our latitudes and longitudes. And you typically say latitude, longitude, but your latitude is actually the y value, like it goes north-south, and your longitude is your east-west. That was a bit of a headache when I was writing this, but just so you know. And if we pull in a color, I think this one would look quite nice. 77D18F. And I'm going to do a plot.show so I don't get all that stuff printed out. So here we can see this is kind of a mapping of where they are. Now it doesn't factor in the curvature of the Earth and all that, but it does. It is a good example. So if we go to maps, we go to Montreal, we can see it kind of follows. Oh wait, my bad. Kind of follows that shape, so it kind of cones out here, and there's none in this little area. And you can see that kind of corresponds to this big airport in a park, right? So there's going to be no hotel or Airbnbs there because there's no houses there, right? So it's kind of cool to be able to take that data set and then actually get a physical map out of just some of the data that they're keeping there. So that's just one example of something you could do. And that brings us to the challenge. So what we're going to be doing after exam season is I'm going to be taking all of you guys, or a bunch of you guys, to Montreal. I still don't know who I'm going with, but it's going to be the people that get this challenge right. So here are the requirements for the challenge. So the price needs to be less than or equal to $200 because I can't spend too much money because, you know, the QDAA, they're going to be paying for it. They're an AMS ratified club, bunch of brokies. But at the same time, I love you guys, so I don't want it to be a cheap hotel. So it's got to be at least $100. So in that range, about $100 and $200. And then the minimum stay it has to be less than 3 nights. So I don't want to stay, we want to stay 2 nights. So we want to find ones that we can, the minimum stay is 2 or 1 or 0 nights. I guess that wouldn't make sense. And then if you solve that, then you can come. But the thing is, I think since you guys are so smart, a lot of you might end up solving it. So I'm going to add in a bonus challenge. The latitude and longitude have to be 0.01 away units, or 0.01 units away from Poutine Bishop. So Poutine Bishop, for those of you who are uncultured, is a poutine store. I was actually in Montreal last week. That's the reason we're using a Montreal data set, because I couldn't think of anything else. And I got this poutine there. Like, look at that fucking thing. It's got a goddamn egg in it. There's like beef and ham. It was awesome, bro. It was awesome. My girlfriend, and you can see in the corner, she got a bus and poutine as well. So we need to be close there, because like, why the hell would you go to Quebec if not for the poutine? So you can see I have a plot that shows the location of Poutine Bishop and then a radius of 0.01 units away from it. So if you can figure out how to do that, then you're able to come along. Okay, so if you want the solution to the challenge, there's lots of different ways you can do it. This is kind of just a very simple, repetitive one. You can obviously come up with more elegant ones, but just for simplicity, we're going to do it this way. So if we're going to want to create a logical array, and we're going to want to use our data frame from above, right? So we're not going to want to use our cheap data frame with only the 150 ones. We want to go above and make sure we are using the data frame with all the values. If you overwrote that, that's okay. You can just run your code from the top and make sure you don't overwrite it this time. So our not cheap data frame is the one where the prices are greater than or equal to 100. So this not cheap will be stored as a logical array. It might be good to actually add the word logical array to the end of that variable name when you're coding it yourself, because one of the things I noticed yesterday was a lot of people would get confused on whether their variables were logical arrays or data frames. So when you're in a language like Python, or in especially something like Colab with IntelliSense, there's no excuse to not use long descriptive variable names, because that can help keep track of the meaning, and especially when you review your code later, you're going to want to know what it is. So if you're at all confused, I would recommend throwing the word logical array onto the end of all your logical arrays and have the word data frame on the end of all your data frames, just to keep track of it, because it can be a bit confusing, especially if this is a new concept for you. So for a logical array, we do data frame at prices greater than or equal to 100. So this gives us all the indices of all the ones that are greater than or equal to 100. And then we want to create our not too cheap data frame. We pass that logical array into our data frame. And then we come up from there, we're going to create a new logical array. So we have our new data frame, and we're going to we're going to use that data frame, and we're going to come up with a new logical array. So we have a data frame of $100 and more. Now we're going to create a logical array of all the ones in that data frame that are less than 200. So we have all these values, right? We've said, okay, take all these ones, make a new data frame. This is our data frame. And now we're saying from here, go and go down to 200 and take these ones. So now we have all the ones that are $1 to $200. This is our valid price range. But keep in mind, this is still a logical array. So we take that and throw that logical array into our not cheap data frame, and that gives us our valid price data frame. And then from there, we use the nights. So the way we index nights is the same way we'd index prices. So we make a new logical array and say the correct nights are the ones that are less than or equal to 2. And then finally, our valid data frame is the price data frame with the respective indexes for the correct number of nights. And then from there, you can use that data frame and plot it. And then now there's some starter code for the bonus challenge, which is this is the poutine spot. So and there should be a theta in the other starter code. There should be a theta. Actually, I'll just throw that in here. Unless I don't think. Oh, it is defined down there. Okay, whatever. So yeah, we have the location of our poutine spot, and we're gonna solve this by using the distance formula, which I previously covered. So we come up with a is close enough function. So this kind of will serve as a way because what we need to do is we need to come up with a logical array, right, to find all the correct values. so from there, what we do is if we pass in the latitude and the longitude, we can use this formula. So it might look a little bit disgusting when thrown like this, but this is the Pythonic way of writing all of that. That gives us our length, or our distance, right? And so we return a Boolean of whether or not the distance is less than or equal to theta. And then, so the way we can create this logical array is we'll do a little bit of building. I tend to do verbose Python code just because it's fun to write in Python. So if we have our empty logical array and we initialize our theta, if we zip through the data frame, the latitude and longitude, so this means we're going to go through the lists in parallel. You could also use indices and call the lists that way, but this is just it's just less writing. So the latitude corresponds to the elements in this list, and the longitude corresponds to this list. So it's not like an n squared type thing. It's just like a 2n. So we're iterating through both simultaneously. So we append our Boolean from this function, right? So we pass in the latitude, the longitude, and our theta. And so this will return true if it's close enough, false if it's not, and then so that gives us our logical array. And then our ideal Airbnbs are the valid data frames at that logical array. And then the way you can plot that is by modifying the starter code with your valid data frames. We're calling them Airbnbs here. And when you plot it correctly, it should look like this. So you can see we have the radius of our poutine shop, and then all the valid Airbnbs are around here. They meet all of our other conditions, and then the ones that are close to Poutine Bishop that are valid are all the ones within the circle. So that helps us narrow down the choice. Don't worry if you weren't able to get that. The second part of the challenge specifically was, I was just thinking if there's anybody that's in like 4th year CS or maybe like Apple Math that's like doing the coding, maybe they get a little bit bored because everyone has different experience levels. I figured, okay, why not just throw a bunch of math in and make this way more complicated than it needs to be? If you were able to get it, congratulations. That's not an easy challenge. So yeah, I hope you guys learned something from this, and I hope to see you all at the next session. Hopefully in person. If not, that's okay. But yeah, cheers and congratulations. If you're watching this, that means that everyone else is struggling with exam season. You know, most of you guys are you're in something competitive. You're either in CS, commerce, or engineering, most of you. So congratulations. Everyone else is dying with exams, and you're probably dying with exams, but you're also taking the time out of your day to learn something new, challenge yourself, push yourself forward. So yeah, just hats off to you guys for learning something more than what's required of you. That initiative is really important. And that's why I encourage you to all, get yourself a nice sweet little treat, get a coffee. When you come to the sessions, I like to bring candy because you guys are working hard, so you've earned it, especially if you're able to solve this challenge. Uber Eats yourself something, go have a beer, man, if you're of age. Yeah, congratulations. I hope to see you all in the next session.